Hi everybody, let's talk about Lockout Tagout. Lockout Tagout, as you know, is under the federal regulations of 29 CFR 1910-147. The 29th Code of Federal Regulations, 1910 means general industry, 147 is the code for Lockout Tagout. Now some of the things that we'll talk about today are the purpose for Lockout Tagout, the requirements for Lockout Tagout, types of hazardous energy, and procedures for a Lockout Tagout program. Now keep in mind, when you go to your safety library, you can always find your written program, which is 90% complete. You might need to add 10% of site-specific type information, your training handouts, your PowerPoints, all the training tools you need to have a successful Lockout Tagout program. Now you will need to write some machine specific procedures as to how or what energy sources you'll need to lock out or tag out for a specific type of machine. When you're dealing with electricity, one thing that we want you to know, as low as 30 volts can carry enough current to kill you. That's why we always say use non-conducting tools, something that's insulated. Check circuits, make sure they're dead before you're working on them. Here's a prime example. There's a light right here that maybe I need to work on this light for a moment. Something's wrong with it, we'll pretend. I go down and I turn the switch off, get my ladder, come up and work on this light. Bob comes in and says, man, it's dark in here, and he flips the switch on and I'm up there working on that light. What do you think is going to happen? Yeah, I'm going to get an electrical shock or an electrocution or something along that line. What should I have done? I should have gone back to the breaker, the source of the energy, locked out the breaker, shut it off and lock it out. That way there's no power going to the switch. So if Bob comes in and turns the switch on, doesn't matter. There's no power going to the switch, no power going to the light. And that would be an effective way to lock out a light before you begin to work on it, or some form of electrical hazard. Now that applies as well when you're talking about mechanical presses or some kind of hydraulics. We'll follow that same procedure. Don't forget to lock and tag source breakers, not the switches. Ensure all control power is de-energized. Discharge all capacitors after lockout. And if you don't remember anything else, just remember E-stop is not Lockout Tagout. Now there are types of energies that we'll deal with. You may deal with all of these, you may deal with only a couple of them. Electrical, mechanical, chemical, thermal, hydraulic, and pneumatic. There are two types of mechanical energy, the hazards that we deal with. One is kinetic, which is in motion. Two is potential, which is stored energy. Now, the kinetic type energy is part of the moving equipment, moving machines, and I think of a couple of examples. One is a rotating cylinder, or maybe a rotating flywheel or something that is, once you shut the power off, it might take a few minutes for that piece of cylinder or equipment to wind down. So you wouldn't want to immediately get in there and work on the machine. You want to make sure that rotating cylinder wind down before you get in there to work on it, because it can cause lacerations, fractures, loss of life, also amputations. Now unfortunately, in my 37 years of doing this, I have run into examples of each one of these, and it's a reality. It's not something we've read about in a book. This is something we've actually put our hands on in time in the past. Now potential energy is energy that's stored in the machinery. It's like weights and springs or pistons under pressure or some kind of hydraulic control. Stored potential energy can be released during work. A great example that I can think of is maybe we're working on something, maybe we need to replace a hydraulic hose or something, and we shut the pump down and we start to take the hose loose, and as we begin to loosen that hose, you know what's going to happen if you don't release the pressure, the hydraulic pressure that's on that hose. When you hit a certain thread, it's going to go psss. Hopefully that's not going to spray in your face or maybe on your body, especially if that's some kind of hot material or hot fluid that's inside that particular hydraulic line. Chemicals. We deal with a lot of different chemicals today. Chemicals have energy that can start fires. They can cause skin burns, generate harmful gases and fumes. Before working, release, drain, or vent chemicals very safely, because that can be an additional hazard. Now, thermal energy hazards, the energy of heat and cold. Hot equipment and fluids will burn you. Cold fluids can also injure you, frostbite or something along that line. Quick release of compressed gas can freeze your skin. Allow equipment to reach a safe temperature before you start working on it. Now, hydraulic energy is energy of liquids under pressure. Pressure can cause equipment to move. That's what it's designed to do. Rapid release can also cause an injury or some kind of ejection. It might kick some kind of part out on you if you don't relieve that pressure or that energy that's built up into that machine. Relieve pressure slowly into a proper container to make sure that you're not injured. Pneumatic injury, or energy I should say, is the energy of compressed gas. Uncontrolled release can cause injuries. Rapid depressurization creates an extremely low temperature. If you've ever rapidly released the contents of maybe a breathing air bottle or maybe an oxygen bottle or something along that line, I would think breathing air bottle, you'll notice as you release or you depressurize that bottle, you notice the nozzle will begin to frost over, will begin to turn white, because the content of that air is coming out of there really cold. Properly vent all systems before starting work. Now, when we talk about some of the lockout, tagout steps, here's some of the things you need to know. Know your equipment and the system. It's important to know what the hazards are. Isolation points, procedures for lockout. Working on unfamiliar machinery is a hazard by itself. Only employees who have been trained and authorized by management are actually the authorized people who can do lockout, tagout, or implement the lockout, tagout program. Now, sometimes we train the affected employees. The authorized employees are the ones who will actually do the work on the equipment and will actually place their locks and their tags on a piece of equipment before starting to work. De-energize the equipment and all of those things. The affected employee a lot of times is the machine operator, who is not involved in the repair, service, or maintenance of that particular piece of equipment, but may be standing to the side somewhere or may approach a piece of equipment while someone's working on it, and it's important that they know about the lockout, tagout program as well. So when they see the lock, they see the hasp or whatever it might be, they automatically know someone's working on this machine. Now, here's some of the items that we'll need to have a lockout, tagout program. We need a written lockout, tagout schedule, or a written program as we call it. Again, your safety library will provide that for you. Locks and tags identified to the worker. A lot of people will write their names on the locks. I know people who have taken photographs of the individual that lock belongs to, and they put it on that lock. Hasp for placing locks on tags. Also breaker clips for electrical lockout. Blank flanges for fluid lines. Valve covers for valve. And plug buckets for other electrical type plugs. Now, locks and tags. Use only those issued to you. Never use someone else's lock or tag. Use the one that has your name or your picture on it. And if you lose it, and it's pretty common over a course of time, we might lose a key, may even lose a lock or something, just ask your supervisor for more equipment or replacement of the locks or the key that you might have. I like to use the 6 steps in, 6 steps out. Prepare for the shutdown, shut down the equipment, isolate all energy sources, place locks and tags, release stored energy, verify the equipment is isolated. Follow these procedures and you will be fine. Number 1, prepare for the shutdown. Understand the equipment hazards. Can't say that enough. Notify other workers of the shutdown, especially the affected people, the ones who are probably the operators or someone that's in the area that maybe helps maintain this machine. Make sure they know that we're about to pull maintenance on this machine, repair or service or whatever it might be. Number 2, shut down the equipment. Use normal shutdown procedures. Turn off all switches, turn them to the off. Shut all valves and controls, and make sure you disable all sources of energy. whether it's electrical or hydraulic or pneumatic, whatever it might be. If there's 3 different sources of energy coming to that machine, then you need to lock down and lock out all 3 of those sources. Number 3, isolate all energy sources, valves, open breakers, disconnects, things of that nature. 4, place locks and tags on the valves, on the breakers, electrical disconnects. Block or disconnect all lines, lock and tag blank flanges. You may not deal with all these pieces, but if you do, keep in mind they have to be locked out and tagged out, and they have to be de-energized. 5, release or block all stored energy. Disconnect discharge capacitors, and keep in mind some of the motors that are on some pieces of equipment have capacitors on them. Those capacitors are designed to store energy. Even though you have locked out and maybe you've shut down the power, killed the breaker or the disconnect, put your lock on it, keep in mind that capacitor could still store enough energy that if someone hit the start button, it could either rotate or jog that machine. And the last thing you would want to happen is to have my hand or my fingers in an area when that machine began to jog or rotate. Block and release springs, block elevated parts, stop rotating flywheels, relieve system pressure, drain fluids, vent gases, and allow the system to cool. Now, going back to discharging capacitors just for a moment, once you've locked out the disconnect or the breaker and you've killed the energy source, one of the things I like to do is go over and hit the start button. If that machine jogs or it rotates, there's a good chance there was power stored in that capacitor. After it does that, I hit the start button again. At that point, I'm pretty comfortable that I've discharged that capacitor. Number 6, verify the equipment is isolated. Check all other workers, make sure they're clear. Check locking devices, make sure they're in place. Check isolation, attempt normal startup. And if you have it locked out, all the sources, the machine will not start up. Return controls to the off or neutral position, and then you're prepared to pull maintenance, service, or repair of that particular piece of equipment. Now, once you've finished the repair, service, or maintenance, then it's time to release it from lockout tagout. Inspect the area for equipment or tools or anything you may have left in there. It has happened many times that someone working on a piece of equipment would leave a wrench or a screwdriver or maybe a pair of pliers or something in the machine, laid it up on the ledge or something. Check it, make sure they're not there. Ensure all machine guards are in place. I accuse maintenance all the time. Once they repair a piece of equipment, they forget to put the guards back on, and the operator comes in, he's trying to operate the machine, boom, we have an injury, and we go back to it and say, oh, where's the guard? Maintenance forgot to put it back on. Everybody doesn't do that, I know that, but in some cases I've investigated in the past, that was the case. Move tools away from the equipment, inform others of the startup, restore system connections, remove locks and tags, restore equipment to normal, and you're ready to conduct normal startup, and you're right back into production. A couple of more rules we want to talk about when it comes to lockout tagout. All contractor and all contract employees must follow your lockout tagout procedures. Whatever procedures you have in place, make sure they're familiar with them, make sure they've been trained on them, and make sure they follow them. Who can remove locks and tags? Only the employee who placed it, or a supervisor after obtaining permission from the worker who placed the tag on the piece of equipment. It says a piece of equipment already has a lock and a tag on it. Do I have to place my own lock and tag? The answer is yes. Each person working on the equipment must place their own lock and tag to ensure their safety. So if I have 3 people working on a piece of equipment, there should be 3 locks in that lockout tagout procedure. So that if I finish my job and I'm thinking it's ready to go, I take my lock off, I can't start the equipment until the other 2 guys take their lock off, and that's to ensure the safety of everyone. Lockout tagout will protect you if you'll follow the procedures and make sure you don't leave out a step. Use proper lockout tagout procedures. Please be careful when working on equipment. Don't end up like this. Actually, in some cases, this is a very minor injury when it comes to lockout tagout. We know of fatalities, we know of amputations, but they're preventable by using a lockout tagout program. Don't forget, go to your library. You'll find your written programs, your handouts, your training tools, the things that you need. You'll need to write machine-specific lockout, tagout procedures, and then you should be good to go on lockout, tagout. Thank you and have a good day.